So in this session we're going to be taking a look at domestic heating systems. So in addition to the control side, we're also going to be taking a look at the wet side. I think it's extremely beneficial to see how the entire system works rather than just learning how to wire something up. So we're going to look at the various components that make the system up. So that will be zone valves, pumps, wiring centres, boilers, etc. And then we're going to see if we can demystify some of the different control schemes. So I'm sure some of you have heard of S-plans and Y-plans. So we're going to be taking a look at those, how they're actually plumbed up and how they're actually controlled. And later we're going to be looking at modifying a system, so adding different components to it, changing components, and then we'll finish off with fault finding. So we'll look at some of the common issues. Just a note on the wet side. Now I have stripped these schematics back to very simple diagrams just to make it much clearer. So the bits that I have stripped off are the most crucial as it happens. Things like the cold fill, the expansion vessels, the expansion tank I've excluded from the drawings. It's just going to get too complicated. We just want to see how the control components work, not how to plumb it up. We'll leave that to the plumbers. So we'll start with the most basic of systems, which is the combi boiler. So the combi boiler has more or less took any interesting controls job out of the residential properties, because it needs a feed and a means of switching the boiler on and off, and that's it. So there is no valves and whatever, or there is, but it's all contained within a box that we don't touch. So let's crack on. So on to our first system. So we're going to be looking at the combi boiler system. Controls wise, this is the most boring for us. There's very little by way of controls. The boiler literally needs a feed to it, live, neutral and earth, and a means of switching the boiler run signal on and off, which can be done via a programmer, a room stat, or normally a combination of the two now. So this is where your Google Nest would sit. Just a very simple on-off control. So the boiler, which is this part here, this contains all the valves, all the wiring and controls, and the pump. The hot water is detected via a flow switch. So once you open the tap, it detects the flow and fires the boiler up. And obviously you've got your radiators. These are connected in parallel, so hot water flows in one end and the cooler water comes out the other to the return leg. And that's it. So here we look at the wiring. So as I said, it's live, neutral and earth, and a means of switching. And then at the bottom here I've actually shown this is extracted from a boiler manual showing you where those switching wires actually go. If we look on the next slide in a little bit more detail, and then we just show this is a wireless system. So you've got your thermostat on the right and you've got your relay box. So again, this is just live, neutral and earth into it, and then the wires will go up to the boiler to switch it on and off. So over to the boiler diagram. So as it says on here, so we're looking at item number 4. So it's saying 230 volt switched live inputs. So we can see we've got live out on the connection block number 3. And then we've just got a live coming in where it says LR. So that's what switches your radiators on and off. So this is where your relay would be connected, or your hardwired thermostat. So next we'll take a look at a very simple animation just showing how the wet side works. So basically we'll kick off with the signal from the programmer and the room stat, and we'll see the boiler fire up and start to pump the water around the radiators. So that's the signal received. So then we get the pump starts up, water flows around, boiler fires up once it's got the water flowing, and basically that is all there is to the system. So again, signal received, run signal, starts the system up. So over to what could be regarded as a slightly more complicated system. First of what we deem a conventional system. So we got away from the combi boiler now, and we've got the separate components within the system. So we've still got a boiler, obviously. We've got a pump, the 2-port valve, and we've got the hot water cylinder. This pipe on the top of the cylinder is where you take off to your hot water taps within the property. Then at the bottom is the cold fill where the tank refills as water's taken away. So the clever stuff for us is revolves around this 2-port valve here. So if we add some of the electrical components in here, so we've still got a programmer and a thermostat, a room stat, unless these two items are combined, which is the norm now. This is coming down to the wiring centre, and from the wiring centre everything is connected into. So the 2-port valve is wired to the wiring centre, the pumps to the wiring centre, and the boiler, tank stat, etc. So have a look at a little bit more detail of the actual 2-port valve. It's nothing more than a go, no go. So when it's open, it allows water to pass through it. When it's closed, surprise, surprise, it doesn't. So in this case, on this diagram on the left, obviously the valve is open, so the water's flowing to the hot water tank and to the radiators. And obviously on the right, it's closed, so it's just going to the tank. It'll all make a bit more sense as we go on. Then we take a look at the electrics, so we will look at these in a bit more detail. So what we've introduced there is an electrical schematic, which is far easier to follow than a wiring diagram. Again, we'll look at these on the next slide. Just a little bit about the bottom. So here we've got the programmer, and these are actually changeover contacts, so it's either in one position or the other. And then this is an extract from a Google Nest instruction manual, and you can see it's just the same setup. It's just a few extra terminals to actually power the room stat up. So if we look on here, on the first line, we've got the central heating on signal from the programmer. We've got the room stat signal. When both of these connections are made, the valve motor fires up on the 2-port valve. Just a note here, and this will come in useful later, what we've actually got here is an AND condition. So when this is made and this is made, this will happen. So I've just highlighted this as being a AND condition. So once the valve motor is made, the motor spins round and then it closes the micro switch, which in turn then switches the boiler on. And then the pump will eventually run when commanded to by the boiler. It's more common now for the boiler to control the pump. The pump actually runs over for whatever time the boiler wants it to. Back in the old days when heat exchangers were cast iron, it didn't really matter if they switched off immediately. But now with the thin steel they use on them, they like to get rid of the heat build up. You know, it's just had a flame on it. Likes the pump to run a little bit longer to take that recently heated water away. So when hot water's called for, again, this contact closes. If the water's cool enough on the tank thermostat closes, and this can also start the boiler. So now we've got two conditions that can make the boiler run. It's either this micro switch being made, which is made once the valve motor reaches the right position, or the hot water signal and the tank thermostat signal together can also switch the boiler on as well, which then in turn switches the pump on. So again, I've just highlighted here that we've got another AND condition. And then within the blue ellipse, we've actually got the combination here where we've got a OR signal. So it's this or both of these can result in an output, which will prove useful as we get further into controls programming. And then we've got the as wired diagram. So we're just showing the hot water signal on here, goes up to the tank stack, comes down. This is wired into here, goes up, and R is the run signal to the boiler, tells it to start up. Then the pump signal comes from the boiler and actually tells the pump to run. On a more modern system, you'll still find older systems where the boiler run signal and the pump are both in the same terminal. So then when we've got the central heated on signal, that comes up to here, through the room stack, comes down to the motor on the heating valve. This is a neutral. I'm not showing the line back, it gets too complicated. So that's your neutral coming from the motor just to make it work. And then we'll see here we've got a permanently live feed going to the micro switch, and then the switch feed coming back, which is usually an orange wire coming back to actually run the boiler. And just onto that other diagram, I've not shown the neutral and earth wired here, but we've got the live, goes to this contact, and then this either makes this side or this side once it's switched on. And then we've got the Google Nest, which is exactly the same down here. T1 and T2 go to the room thermostat to power it up. That's the only difference. And then we have a quick look at the 2-port wiring colours. These are standard colours, so even between different manufacturers of valve, these are usually the same. So we've got the brown, the motor live, the blue, the neutral. The grey is the permanent live to the micro switch, and then the orange, as we said, was the switched live from the micro switch. And obviously we've got the earth. Now we'll take a look at the schematic in a little more detail and animate what's actually happening. So we're going to start with the hot water on signal. So we'll see that goes up to the tank thermostat. That decides it's cool enough and closes, switches the boiler on. The boiler then switches the pump on. So once the water's warm enough, the tank thermostat says, no, don't want no more. So the pump goes off. And next we've got the central heating signal going on. Spins the valve motor around, makes the micro switch, which then switches the boiler on. The boiler then once again switches the pump on. And round again. Tank thermostat for the hot water, boiler run, pump run, hot water's hot enough, tank thermostat opens, boiler goes off, central heating now comes on, spins the valve motor around, makes the micro switch and switches the boiler on, and then the boiler switches the pump on. That's it. In this animation we'll take a look at the wet side of the two-port system, where there's a single two-port valve controlling the heating. So we'll kick off with the hot water only. So signal received, pump starts up to the valve but not past it, through the tank, and the blue line just shows that the water coming out of the tank is a little bit colder than when it went in, so it's given some of the heat up to the tank. This is what you call a indirect heated tank, so you're not warming, you're warming the pipe up that's in the tank, not the water itself. And then there's a transfer of heat from the pipe, which is in a coil, not a straight line like it's drawn. It's more difficult to draw a coil, and that in turn warms the tank of water up. So next we'll have a look what happens when the heat signal's received and it opens the two-port valve up. So now you see the flow into the radiators. And it literally just goes around in a circle until the signal's lost. Now in this system you can't have radiators without hot water. There's nothing to stop the actual water running through the tank as well, so all the time your heating's on, you're actually warming your hot water up at the same time. Now this may be a good or a bad thing depending on your view. As we mentioned in the last animation, we can't have central heating in this system as it stands without having hot water also. So this isn't such a terrible thing, because you've always got a tank of hot water, but you've got no control over the temperature of the hot water either. So that it'll warm up to the temperature that the boiler's actually set to, not what the tank thermostat's set to when central heating's in operation. So the challenge is, how could we improve this system so we can have independent hot water and central heating? So we'll leave that challenge with you. See if you can figure it out on the wet side and how we would wire that in on the control side.